Well, hello and welcome to the wild and wacky world, man, I could almost not say that, of R. Now this might look a little bit different from R you have on your computer because it's on a Mac, but it's going to behave exactly the same. So we'll just try a few things on here to get an introduction, run a little bit, and then you can try it. Now how I got this was just by clicking on the R icon. Okay. Well, there's a couple good ways to get data. One way, two of the simplest ways I'll give is, say our data is 1, 10, 21, and 8. And let's go a couple more, 9, 10, and 12. Okay. So we can use concatenate, which is a C. And by the way, there's two ways of reading stuff in. So I could use any name I want. I could call this Fred if I wanted to. And it'll save it in Fred. By the way, there's a second way. If you want to go back and change anything, what you can do is you hit the little up arrow on your key and you can go back and edit stuff. There's a second way to read data in. Instead of using an equal, you can do a less than line. It does the same thing as it's going to take those numbers, it's a vector, and call it Fred. Okay. Now I'm lazy, so I usually just do equal, but you know, the really classy people like to do the less than and the hyphen. Okay, so in R, one nice thing is if you type the name of something and don't put an equal or anything else, you get to see what's inside that thing. So those are the numbers that are inside X. Now what are some things you can do with X? Well, one thing is you can edit. If you see, let's say the second one of those should really be 11. So I can edit X. I say edit X, and out comes a window here. And I can go up here and change that one to 11. Now when I'm all done editing, I just hit this thing and say save. And now you'll notice it is edited. Okay. So from 11 down to 10. And note that I did the second one right there. Has been changed from 11 to 10, in case you make an error. Another way to do the same thing is that if you put square brackets, you can look at individual things in the data. So like the third one is 21, the fourth one is 8. Well, let's say I wanted to change the fourth one to 18. I could say x of 4 equals 18. And let's see. So that gives you a way of getting at any of the parts. Now, other than this concatenate, there's another one that's real nice, another way of getting your data in, called scan. And you can just put numbers in here like crazy. In fact, you can just cut and paste them. So I can even put things on the two things the same line. And all I do is hit return at the very end, and there's what's inside Y. 50, 12, 11, 100, 20, 10, and 4. Okay, I think we'll have to calm down after all that excitement. Now what can you do with something like X once you've created it? Well, there's a command length, which tells you how long it is. That's handy if it's a huge vector and you want to see how many values are in it. You can essentially do math to any of these things. So if I want to square everything and then add 4 to all of them, I get that. Okay, we'll see a little more math in a while. I can even add two vectors together. Let's say, how long is X? X is 7 things. So let's add a new vector that was. By the way, this notation, 1 and a number, and a colon and another number, that creates the numbers 1, 2, 3, 4, 5, 6, 7. It's a shorthand. Okay. And I'll see what I got. Yep, there they are. 1, 2, 3, 4, 5, 6, 7. And so X is the same length, so I actually can say things like X plus 2 times Z, and I'll get a vector. And in fact, if I want to store that, I can. Okay. And there's lots and lots of stat things built in. So let's go back to X. I can get the mean of X easily, the variance of X, the standard deviation of x, the median of x, and there's bazillions and bazillions of things. What's another good one? I can even plot x. Now that's not real exciting because it's just a single variable. So if we look at it, we get a bunch of points here. Okay. So this kind of shows a plot. There's another type of plot I could do. If I say plot, oh, by the way, I hit the up arrow. If you hit up arrow, you get back earlier lines that you did, and you can change them. So up arrow, you can say type equals L, in quotes, and that one will give a plot that's connected by lines like this. Now you must admit that looks cool. Okay, maybe you don't have to admit that looks cool, but you think it looks cool without admitting it. Let's see. If we have two things, remember we have the x and, let's say, x and z. Those are two vectors of the same length. I can do a plot that looks like plots pairs of things against z. I'm going to do a thing called PCH equals 19. What that does is it fills in the dots so they're big points. So here we go. Notice now I've done a scatter plot. I've plotted the x values against the z values. All right. Another thing is a histogram. So those things can be a pain to do, but not in R. And by the way, these plots, you can go up to the file statement and save these as PDF files or a variety of other JPEGs. Okay, so there's histogram, there's the values of x, there's the frequency that they occur. So that can show you the shape of your data. Okay. Sometimes with a big data set you want to sort them in order. Sort does that. And I think that'll do it for the main type of just general commands to see what your data looks like. Now let's try a calculation. Let's say we knew the population size was 1,000. Our data size is the length of x, which, well, let's just do x, which is 7. Say it's 7. We can do calculations like this. Standard error equals square root of, let's go, it's n minus little n over n times variance of x over little n, and there's our standard error right there. So if we wanted to get a confidence interval, we could go mean plus 2 standard errors. Oh, wait, didn't I calculate it? Oh, mean of some. I have to make mean of something. Mean of x plus 2 times standard error. Notice mean is a function, and whenever you have a function, you put parentheses after it, and that's what it operates on. So it takes x and takes the average. Okay, so that's the upper bound of the 95% confidence interval. And here's the lower bound of the 95% confidence interval. Okay, that's almost it. Let's look at some general commands you can use. One command that's very, very handy is ls. It tells you what variables you've saved. Okay. If you want to get rid of one of them, you don't like it, you can get rid of Fred there. So that's kind of editing the variables. So I didn't want Fred, so I got rid of it. Another really handy one is help. We'll talk about help files more in the future, but any command that's built into R, you can say help, and it gives you this help file, which gives a rough description of what it does, and it also tells you what arguments you can put in it. Here's a fast tip on those. If it says something equals in this description, it means those are things you don't have to put in. They have defaults. 0, and so mean, you really only have to say mean of x, and it computes an average. Okay. Another one that's very, very handy is if you can't remember, you want to do a standard deviation, but you don't know what the function is that does standard deviation. So you can do help search, help.search, and in quotes you say something like standard deviation. Okay, standard deviation. I hit return, and up comes a window which shows 4 commands that with the help file it mentions standard deviation, and I go, aha, this looks like one right here. Stats, by the way, is the main package. These are all other packages I've loaded in, so there's bazillions of those. And if I click it, can't really see it, but if I click it, it opens up the help file for standard deviation. And I think that will do it for now. So remember, you know what we've seen is we see how to put data in. There's snappier ways to read it from files and stuff. But if you're typing your data or cutting and pasting your data into it, we've seen how to do that. We've seen how to do computations like standard errors and means and medians. We've seen how to change individual data points if you made an error in entering them. We've seen how to do calculations on them and to get some nice plots. And now I will sign off. When I say quit, it's going to ask me if I want to save the workspace. That means next time, if I save the workspace, next time I sign on, all on the same computer, of course, all the variables I created will still be there. I generally don't do that. I would just paste them somewhere and use them. Reload them next time, but so I will say don't save. But if you want all your variables to show up again, so if you had to quit in the middle of a calculation, you can just hit save, but I'll say don't save. Okay, sounds good, and I think that should do it.